said matter is anything that has mass and occupies space. So we have considered the three states of matter as well as their differences. So apart from these three states, there are other important things that are attached to this state of matter. And that is what we are going to look at. Because from the first topic I wrote on the board the other time, I said the topic is nature of matter and separation techniques. So the nature of matter involves some important terms which we are going to discuss now. And these are atoms, molecules, elements, compounds, and mixture. So we are going to take each of these one after the other and look at them in terms of definition and as well as how to identify them. Atom. An atom, by definition, is the smallest particle of an element can take part in a chemical reaction. Please, when you are defining, that is where some students do make mistakes. When you are defining, you make sure, because there are some driving words. Chemistry, we have our own languages, and nothing can be changed. Although you can define it in your own words, but those driving words must be present. Look at this definition. An atom, this word smallest, must always be there in your definition. And apart from that, particle of an element, chemical reaction. All these are driving words. Irrespective of the way you put it, they must be present. A good example is, as a matter of fact, in your integrated science, in your junior secondary school, you learn what an element is, atom. Of course, you are familiar with hydrogen, oxygen, nitrogen, and lots more as a typical example of an element. Each of these elements has a smaller or the smallest particle of it, which cannot be broken down. And this particle is what we refer to as an atom. So, if I ask you, an example of an atom of an element is hydrogen atom, oxygen atom, nitrogen atom. Is that making all elements can exist in form of that smallest particle called an atom. Alright, apart from that, we also have molecules. A molecule is the smallest particle of a substance which can exist alone and still keeping the properties of that substance. That is a molecule by definition. The smallest particle of a substance, not an element this time around, which can exist on its own and still keeping the properties of that substance. So there is a relationship between an atom and a molecule, and that relationship is what we call atomicity. So atomicity by definition means the number of atoms, okay, in a molecule is called atomicity. Atomicity. What do I call it, class? Atomicity. Interesting. That atomicity is very important, and it relates both atom and molecule. Atomicity can be monoatomic if a molecule contains one atom. It can be di if there are two atoms in that molecule, and it can be poly. Anything more than two is what we refer to as poly. So let us look at that in a tabular form by looking at the differences between atoms and molecules. And this time around, I'm going to give you in terms of don't forget, we are still learning chemistry, so it's as important as anything. Alright, this table here give some of the differences between atoms and molecules. Here we have molecule, formula of molecule, and of course we have atomicity. Don't forget, atomicity is the number of atoms in a molecule of a substance. For instance, if we have argon, the formula of argon molecule is Ar. When we get to elements and symbols of elements, I'm going to make reference to things like this. Although it may be strange to you, this is what we call symbol or formula in terms of molecule. Symbol for an element. We are coming to that. Alright, this is the formula of an argon molecule. You can see, if you look at this, the whole of this represents a single entity. We have one atom in this molecule, and that atom is argon. So the number of atoms here, which is atomicity, is 1, or we call it monoatomic. So argon is a monoatomic molecule. There was a question in one of the UTME exams around 1990s or whatever. They asked the question that an example of a monoatomic molecule is, so they gave options. In the options you have neon and some other gases. So all noble gases, and that's another thing that we are going to discuss later in our class. All noble gases are monoatomic. Another example of that is neon. The formula is Ne. We have one atom of neon here, so the atomicity is also 1, which is monoatomic. Another example is helium. The common gas used to fill balloon. Okay, the formula is He. We have one atom of helium here, so the atomicity is 1. Which is also monoatomic. For diatomic molecules, that is molecules containing 2 atoms, we have oxygen molecule, which is O2. We have 2 atoms. This subscript indicates the number of atoms you have in that molecule. So we have 2 atoms of oxygen here, so the atomicity is 2, and we say it is diatomic. What do I call it, class? Diatomic. Another example is nitrogen. A nitrogen molecule has a formula N2. Of course, you can see, similar to oxygen, we have 2 atoms of nitrogen here. So the atomicity is also 2. Alright, I said nitrogen is similar to oxygen molecule, also exists as N2, and it is diatomic. Another diatomic molecule is nifluorine and other halogens. The formula is Cl2, and the atomicity is also 2, which is diatomic. So any molecule that contains more than 2 atoms is said to be poly. And examples of that are ozone molecule. The formula is O3. Please be familiar with this formula. It's O3, and the atomicity is what? 3. 3. Why did you say 3? Because there are 3 atoms. So the atomicity is 3. So this is polyatomic. Another example is sulfur molecule. Usually your rhombic sulfur. The formula is S8. What's the atomicity in this molecule, class? 8. Thank you. And it is said to be polyatomic. So based on this table, of course, you can recognize that there is a relationship between atom and molecule. Please take note. Then the next particulate of matter is element. Yes.
So if I understand you clearly, can we relate the definition of atom to that of cell in biology?
Yes.
Smallest.
Of course, yes. Atom is the major building unit of anything that